Good morning, everyone. In the last session, we discussed about the one of the important example called tree set here. Now we identified a different method how it is working internally, like add method, same way add all method, remove method, and remove all method. So and this particular 2RA method how it is working, and we discuss about the iterator. Okay, so we'll continue the remaining method what we are having inside this particular tree set. Now you can see tree set is the one of the implementation of this particular set interface. So that what we can do, so we'll identify this particular retain all. Retain all basically what it will do, if you're trying to pass any collection, so those collection values are available in the tree set will make as it is, and the remaining like so the those are not related this particular tree set here, those are records are removed from this particular tree set. So if you observe carefully, now here what I'm doing here, I'm trying to call ts dot retain all. So whenever I'm trying to call this particular ts dot retain all, now what I will do here, I'm going to pass the collection. So which collection we can pass? Something like linked list I'm passing here. Whenever I'm trying to pass this particular linked list, now what happens internally? Whatever the records are available inside this particular linked list, and these records are available inside this particular tree set. So those matched records are, they are not going to remove from this particular tree set, and unmatched, like whatever the additional records we are going to have, those records are going to remove from the this particular tree set. For example, what are all the linked list we are having? So first one is 10. Okay, so double values I'm not adding anything. So just simply integer values I'm adding. So 10, 75 and 96. Okay, only 3 we are having. So 10, 75 and 96 we are having. Now if you observe carefully, so inside this particular tree set, what are the values we are going to have? The same value, something like 45 and 89, same 96 and 56, and we'll have a 12 and 123. Finally 54 we are having. Along with this particular 54, we are going to discuss about these values, something like 10. The 10 we are going to copy this, and 75 we are copying. Getting the point? 75, after 75, 96 also. Now if you see why I'm adding these three also, why I'm adding these three particular, why I'm adding this particular three elements here. This is important, we need to understand. Now if you see the line number 22, what I'm doing here, I'm trying to call add all method. Getting the point? So whenever we are calling this add all method, what I'm passing here, this particular linked list I'm passing here. Whenever I'm trying to pass this particular linked list here, these three objects like the 10, 75, 96 objects also we are trying to store inside this particular tree set. So this is the tree set object reference, and this is the linked list object reference. So linked list is contain 3, and tree set is containing so more values here. Getting the point? This is we need to understand very carefully. And finally, now what I am doing here I'm trying to print this after this particular calling the retain all method. So retain all basically what it will do, these objects are available or not, it is going to identify. If this particular objects are available in the tree set, this object will keep as it is, and the remaining objects are going to remove. Now what you understand here, up to this 54, up to this particular 54, all the objects are going to remove from the tree set. So these objects are no longer available. Only the objects will have 10, 75 and 96 here. So why we'll have only these three objects? Because what we are passing as a parameter, the collection parameter we are passing as a linked list here. Whenever I'm trying to pass this particular linked list, internally it's matching this particular records here. Only these three records are going to match here. Once this particular three records are matched here, this remaining unmatched records are going to removed from the tree set here. Okay, This is one of the important example we need to understand here. So let me save this example, and I'm going to run this example after this, after calling this particular retain all. Now you can see, so only 10 value, here we are having the 10 value, and after the 75, after that 96. Only 3 records we are having. Getting the point? Only 3 records we are having. The remaining records are removed from this particular tree set here. The remaining records are going to remove from this particular tree set. So this is very important information we need to understand how this particular tree set is calling internally a retain all method. Okay, this is the one of the important example we identified here. Now after this, now what I will do, what is another method we are having? Something like to clear. So clear will do the later, because if I'm going to do this particular clear now, it will remove all the records. Simply, if I want to remove all the records from this particular tree set, we can call this particular clear here. Okay, we can call this particular clear information. Now what I will do, after this particular clear information, we'll move on to the list we completed set, sorted set related. So what are the sorted set related we need to understand? First one is comparator. Okay, first one is comparator. So how we are going to write this particular comparator? This is important. Now, whenever I'm trying to run this particular example, so which constructor we are calling? Here we are calling this particular default constructor. Now if you observe carefully, I'm going to create one comparator here. So inside this particular tree set only, inside this particular tree set, we are going to create one comparator. Okay, tree set comparator I'm trying to create, and this particular tree set comparator internally, what it will do, it will try to implement. Okay, so this is the comparator we are having, and here it is expecting the type. What is the type we can provide? What is the type we can provide? If I'm going to provide something like a double, what happens internally? We need to override the method. So what is the method we need to override here? Now if you see, we are having one unimplemented method like a double. So double parameter, first parameter we are passing, and the same the second parameter we are passing. Now what we can do? Getting the point. So what we can do this particular compare. Now you can write the integer logic here, because finally, so by default we are trying to return 0. Getting the point. So whenever we are trying to write this particular 0, what happens internally if I'm not modifying anything? Okay, observe carefully. If I'm not modifying anything, this comparator I'm going to use here. This comparator I'm going to use this particular inside this particular tree set, and if I'm going to run, I'm commenting this particular retain all. Okay, I'm trying to comment out this retain all as well as the remove here. Now we'll see what happens internally. What happens internally? Getting the point. Only we are getting 45 here. Getting the point. We are getting only 45 here. Now what do you understand here? Why I'm not getting the remaining values? Getting the point. Why I'm not getting the remaining values? This is important here, because whatever the comparator we implemented, so this will work internally. Okay, this will work this particular comparator internally. Now if I'm going to debug this code, we'll understand how it is working internally. So this is the add method I'm calling, treesetter.add method. Now I'm calling this add method here. After this particular add method, what we need to understand, put method I'm calling. So what is the root? Right now we don't have any root. Now we are calling the first record this. So this is the root record we inserted here. After this, now we are moving into the second record. So second record here, we are calling one more time, and now you can see root. Root is not null. So we are calling the comparator. This comparator we are passing here. Getting the point? Here the comparator will get an object here. Now you can see. So CPR we are having some information. So this particular CPR it's not null. Okay. So if this particular CPR is not null, so why we are getting this comparator basically? Here we are passing here. Here we are passing this particular comparator. So whenever we are trying to create this particular custom comparator, we can pass as a constructor parameter to this particular tree set. So whenever we are trying to pass this, now if you see, here I am trying to set this. Okay, internally, here we are trying to set this dot comparator dot is equals to this particular comparator I'm passing. Getting the point? So this is the comparator we are passing here. Now what we are doing here, after passing this, the object we are getting. Whatever the object we are using, this object we are getting. Now I am loading parent information. And what is the CPR we are getting? So CPR we are going to call the comparator reference. And what is the key I am passing? 89. And what is the T dot key we are passing? 45. 45 we are passing. So finally, what is the result we are getting? 0 we are getting. 0, this compare method is returning 0. Where we implemented this compare method? So here, this one. So this compare method is going to call whatever this particular tree set comparator we are writing here, the tree set comparator, it is going to call this compare method. Okay. Now, from this, once it is called here, what is the value it will return? Every time we are returning 0. Now you can see 0 we are returning. 0 we are returning. So whenever we are returning this particular 0, so this condition will not satisfy, this condition will not satisfy, and so else section we are satisfying it set dot value. So T dot set value. What is the T? T is the parent value. Okay. Now we'll see what happens internally. Here, whenever I'm trying to call this, every time we are trying to replacing the value. Okay. We are trying to replace the value, but the value we are not using. We are focusing on the keys here because we are working on the tree set. We'll focus more onto the keys. Now, because of that, only the one object we are getting here. Getting the point? Only one object we are getting, that is called 45 only. Now, what do you understand here? So this is because of this particular compare method we did not implement it properly. Okay. So we did not implemented this particular comparator properly. So this is because of this particular. This is because of the comparator we are having an issue. Now, what you understand this? We need to override the one of the important comparator here. So because of this particular comparator, then we can easily understand how it is going to working internally. Okay. So now what we can do? We need to write this particular comparator inside the whatever the class we created. Here we need to write the code. So if this particular 01 dot compare to this one. Okay, now if you see, I added some logic here. I added this particular 01 dot compare to this particular 02. Now what happens internally? If I'm going to run this example without this particular debug, now we'll see what happening internally. We are getting all the values. Okay, so 1041 to 123. For example, if I'm going to modify this, if I'm going to modify O2 and here I'm making O1. Okay, the compare to method I'm trying to make different values here, and now again I'm going to run the same example. Now observe, this is the highest value. From highest value to lowest value we are getting. Getting the point? From this particular highest value to lowest value we are getting. So earlier lowest to highest we got here. This is important here. But how we are modifying it? Inside the tree set comparator. So this is, I modified this. Because of this, the values are, now it's coming in the like smallest to highest and highest to smallest we are getting here. Getting the point? Now we understand here. This is very important here. this comparator, how it is working here, we are trying to implementing the comparator, and we created one class here, and we override the one of the method called compare method, and because of this particular compare method, based on our requirement, we are converting the objects here, like ascending or descending order. Getting the point? So this is the one of the important example we need to understand how this particular comparator is working internally. Okay, so now if what we are doing here, so we implemented this comparator. So this comparator we implemented so far. Now we need to work on the subset here. So how we can work on this particular subset here? Subset basically it is a simple the method based on the within the range. Like whatever the range we are going to provide within this particular range, it will try to copy the values. Okay, this is important. Now if we observe carefully how this particular subset will work. 3s set dot subset I'm passing here, and we need to provide the double from element to two element here. What are the from element and two element we need to pass here? This is important, we need to pass here. Now you can see, and here I'm going to pass 123 dot 63, because this is the first element we are trying to converting as a so descending order here, and from here I'm going to copy 75.23. Okay, 75.23, and whenever I'm trying to providing this particular within the range value, now it is trying to returning as a sorted set dot subset here. Okay, so if I'm going to print this, how it is going to print this? So sorted set basically it is a one more array. Get in the pen, one more array. Now I'm trying to use for loop and double do. So do while I'm going to use, and subset. And here I'm going to use the same println dol. Now you can see whenever we are calling this particular this subset here. Oh, let me comment out this. This I need to comment out so that we can understand here how it is going to work internally. Now you can see what happening internally. So this is 1, 2, 3 to 89. So this is the one of the sublist here. One of this particular sublist we are getting here. Carrying the point. This is important. We need to understand here how this particular example it is working internally, because subset. Carrying the point. Subset is one of the substring method what we discuss in the string related. Now this is our original array. So whatever the range we are going to give, if I'm trying to give from 0 to this is the range, it will copy this. Okay, it will copy this and it will create a one more collection, and if the collection look like this, we can print the some values like this. Okay, this is the subset of this particular collection, and this is the original collection. Not only this starting onwards, you can give from anywhere, any location we can give. So if it is not satisfied, you can give like this. So here I created three diagrams. First one, it is trying to copy from 0 to some range of value, and this particular second one, it is trying to copy between this particular tree set, and another one, so middle to it is end of the particular tree set. So any locations we can provide, but whatever the location we are providing, the value should available here. Okay, the value should available inside this particular subset here. Inside this particular subset here, this is very important information we need to understand here how this particular subset it is going to work internally. Okay, so now finally what we need to understand here, this is the subset method we discussed here. Now we'll go to the another method, set method. So head set basically what it will do. So up to the two element. Okay, up to the two element here. So whatever we want to copy from this particular two element, we need to pass it so that it will copy 0 to the within the range of value, whatever the value we are going to create here. Now you can see I'm commenting this section, and finally I'm calling ts dot headset. So headset basically if I'm trying to give two element, the two element if I'm trying to give as a 75 dot 75.23, and what is the return type it's trying to returning? It is trying to returning say one more sorted set here. So if it is trying to returning one more sorted set here, what we need to understand here, so this is the another way of writing. Now you can see here directly I'm trying to returning this particular for each loop, and here I'm going to make as a double, and the do while I'm trying to make here. Now finally I'm calling the method within this particular loop here. Okay, within this particular loop I'm trying to call this particular method here. Now you can see how this is another important example we need to understand here, how it is calling this particular ts.headset method. Now we'll see how this particular ts.headset method will call internally, because subset we already identified, because we are giving from element to and to element within the range the values will which going to be copied, but here we are giving only one value. So whenever we are giving this particular one value, how it is going to copy, this particular value, we need to understand here. Now I'm calling, so double value, again I'm calling this particular headset. So internally it is calling one more headset here. Getting the point? One more headset method is calling, and here we are passing the second parameter as a false here. Now we need to understand here why we are passing this particular second parameter. Getting the point? Now if I'm going to run this, this is the inclusive we are passing as a null. Now you can read this where we are having. Okay. So we don't have a parameter, just it's trying to throw the exceptions internally. First we'll get in a class exception, later we are throwing in a null pointer, later we are going to throw an illegal argument exception. These are the three exceptions we are going to throw. So finally, now what I'm doing is new tree set. So I'm trying to create a one new tree set object, and here we are trying to call the one more method called map.headmap method. So if you observe carefully, this subset also, whatever the subset method we discuss here, this particular subset method also internally, it will create a new tree set object internally. Okay, right now how it is creating like this. So new tree set object, same way the subset method also will do the same, and whatever the return value we are going to get from the tree map, the value will set into this particular tree set. Okay, anyway, we need to debug this particular head map, and here we are passing false value, and the two element we are trying to give as a 75. So again I'm trying to move. We'll see this is the head map we are trying to call, and internally what I'm doing here, I'm trying to call this particular constructor. I'm calling this particular constructor. So what is exactly this particular constructor will do? Ascending submap. Getting the point? Here also we are trying to create a ascending submap here, and we are passing this current object. Current object will containing these are all the elements here. Okay. So finally, these are all the true values and null and some of the true values we are providing, and this is the key. Up to this particular key, we are going to copy the element. Now we'll see how this particular constructor is implemented. Now if you see, it is calling the super. It is calling the super class constructor. So what is a super class constructor? So this is the current class we are calling ascending submap. Now internally it is trying to call this particular navigable submap here. Okay, navigable submap. Now what you need to understand this, whenever we are trying to call this particular navigable submap here, we need to understand this how it is calling internally. Okay, now I'm calling super class constructor. So if you see, this is the navigable superclass constructor we are calling it, and this is the tree map we are passing it. So this particular M will contain internally all the elements. So far, whatever the elements we inserted here. So these are all the elements we are having. getting the pen. Now, after this, now what I'm doing, I'm trying to executing this. I'm trying to executing. So what is the, so start, what is the value we are having? Maybe true, I hope. Okay, this value we given as a true, but from start, if it is not a true, it will satisfy this particular condition to end. So we need to identify what happening internally, this particular conditions here. Okay, it is returning false. Why it is returning false? Because these two sections we made as a true values. So we'll see from start we are having true value and to end. So to end also we are having false. Okay. So here this condition is returning true and this condition it is returning false. So this is important, we need to understand. One condition returns true and another condition it is written false. Okay. So whenever we are trying to do like this, now finally this entire expression is written as a false here. Okay, so what you need to understand here, one second. Okay, now observe carefully what I'm doing here. Here, this is very important information we need to understand here. This section is not satisfied here. Okay, this section is not satisfied. If this section is not satisfied, it will go to the second here. So from start here, basically it is a true value. Here you can see it is a true. Whenever it is true, it is returning as a false. So this particular section also will not satisfy. Now we need to identify the last here. This particular to end is satisfying here. Whenever it is satisfying this particular to end, what is the high value we are having? 75. Okay, here we are passing. Here we are passing same values here. Whenever we are passing this particular same values, what it will do internally? It will try to return the 0. Okay, it is trying to return this particular 0 value. After this, after returning this particular 0, now what we are doing here? We are trying to setting here. We are trying to set. So these are all the values here, and we need to use this particular high. This is the variable we are going to use where we are trying to providing this. Now this is the same value we are having 75.23. After this, we need to identify wherever we are trying to check this method. Okay, wherever we are trying to check this particular method, we need to identify this. We are calling on this, and head map we are calling. How this section is implemented internally. One 23, 96, 96 calling, 89. Okay, up to the 89. Why this particular 75.23 is printing? It is not loading because so up to this particular value, whatever the value we want to print, the particular value only up to the range of this particular value only it will print this. So now you can see. So 1 2 3 it is printing. Okay, 1 2 3 it is printing 96 96. So two times it is printing it, and finally 89 is the last value. So for example, if I'm going to print this, you'll understand here how this particular examples are printing internally. Okay, so this is we are calling from the headset method, and this is the TS internally. It will call the iterator and it will print all the values. Now you can see up to this 89, because why it is not loading this? So this is the range we given. Up to this particular value only we need to copy the value. So this is the headset method. Now if I'm going to copy tail method, something tail set, something we have tail set method we are having, we can pause this, and here I'm trying to give from which element I want to copy. So again I'm giving the same 75 here. If you observe carefully the differences here, from this particular 75 it is trying to call the 10 here. Okay, now you can see here to here it is called. Getting the point? This is important, we need to understand here. This method basically, it is a tail set. Okay, and this method we are going to call it as a headset method. So headset method basically what is doing, from beginning index, like beginning value, it is trying to call the whatever the range we given. Getting the point? So beginning value, it is trying to call the up to how many elements we want to copy. And another one we are having, so from the whatever the value we are providing, from element to end of this particular records here, end of this particular tree set. So this is very important, we need to understand. These are all the differences we are having: headset method and tail set method. Getting the point? Headset method and tail set method. This is the another important information we need to understand here. Okay, so any questions regarding these two methods, the headset method and tail set method, what we discussed, and the differences we identified here. From first index to last index, if we want to load, like we can move on to the headset method, whatever the end value we are going to provide. So within the end value, how many elements we are going to have, all the elements we are going to load. And the tail set method basically from middle element to last element, from middle element to the last element, whatever the middle element we are going to provide, it will load all the values. For example, if I'm not interested in this particular middle element here, you can give 1 2 3 only. Directly, you can give 1 2 3 dot what we are having 63. If you give this, it will load all the values. Now you can see 1 2 3 dot 10 like up to the 10 records we loaded, whatever the 10.41 value we are having, and same thing now you can see it is matching with this. But this is the important here, what is the starting element. Okay, this is the starting element. From where we are starting, we need to specify the value, and the another headset method, from where we want to stop this, where we want to stop, the another important element we need to specify here. Okay, these are all the two important we need to understand. Now another, you can see the headset method is expecting up to the what is the two element, and the tail set method is expecting what is the from element. Now these are all the important information we identified. Now we'll move on to the first and last method, how it is implemented inside this particular tree set. So before going to discuss, someone asking the question. So these methods are the core Java concepts only. These are not the Spring related section. So far we are not started any Spring concepts yet. Everything is related to the core Java only. Okay. So coming back to here, we need to call these two methods. So first method as well as last method. Now what I'm doing here only, I'm going to call the first method as well as the last method, how it is going to print this. TS dot first method. Whenever I'm trying to call this particular first method, what happens internally? The first method will return here. Now you can see the first method, what is the value it is returning? Something like 123 dot 63. Getting the point? 123 dot 63, this particular value it is trying to load. Getting the point? This is important, we need to understand here. Getting the point? This is one of the important information we need to understand here. Now after this, now what I'm doing here, I'm going to expand this particular first method, how it is loading this. How it is loading, because we identify the diagram, each and every value internally it is trying to store in the entry record. Okay, so how from the entry record is trying to load. Now let me put a breakpoint here, line number 24. We'll debug this particular first method, how it is internally implemented this. Okay, how this particular method is implemented internally. Who is this? One second. Okay, now observe carefully. I'm trying to call this particular first method. Now I will move inside this particular first method, how it is implemented. Now you can see what I'm doing here. I'm trying to call this particular first key. Views who is unmuted here. Okay. Now you can see, now what we need to understand here, this is important, we need to understand first method. How this particular first method is calling internally, it is calling m dot first key. Okay, this is, we need to identify how the m dot first key method internally it is implemented. Now we are calling the key method. So we discuss here get to first entry. Get in point. This particular get first entry we discuss whenever we are trying to work on the key iterator. So inside this particular key iterator, we pass the value this. Okay, we pass this particular method as a parameter. Now, so this is the second time we are trying to discuss about the this particular get first entry record here. Now you can see I'm calling this. Now this is the root we are having here, and here what you need to understand this. So this is the P basically. Okay, root record. So what is the root record we are having? Something like 89. Okay, 89 is our root record here. So once we are identifying this particular root record, now what you need to understand here? From here, we are trying to repeat this particular loop multiple times. So P not equals to null, and we are trying to use this particular while loop P dot left. So P dot left will contain first record as a 96. Okay, 96 we are having. 96 again we are trying to set into this particular parent here. Now you can see. So one more time this particular loop is repeating. So this is the last iteration. Okay, this is the last iteration we need to understand P dot left. So 1, 2, 3 we are getting the point. This is important. We need to understand here. So once we identify here P dot left here. So this is the P dot left we are loading. Now observe again we are loading. Now this P dot left we don't have any records. So this is empty. Empty. Observe carefully how this diagram is created internally. Because so we discussed 89 is our root, and left side we are going to have 96, and 96 left side again we are having 1, 2, 3. Okay, again we are having 1, 2, 3 here. Okay, so 96, so we identified this. Now what you need to understand here, this is important because we are loading descending order, because the bigger value we are trying to set in the left side, and the small value we are trying to set into the right side. Now you can see here we are having 45, getting the point, and internally we discuss about the left side we are going to have 56 here, and 56 internally it is contained the left side something like 54, getting the point. So just I'm giving the whatever these particular records are going to created internally. Okay, and the right side something like we'll discuss about the 12, and this particular 12 right side will contain the 7. Okay, these are all the records we are having so far inside this particular tree set here. But now you can see we are calling on the every time P dot left to P dot left. So we are loading this records from the 89 to this records we are loading. First of all, we are loading the 96. From the 96 we are loading this particular 1, 2, 3. Okay, 1, 2, 3 cannot have any left side and right side value. All are null values. Getting the point. This diagram is important whenever we are discussing this particular tree set. So now if I'm going to expand this P dot left to null I'm getting. Okay, whenever I'm null I'm getting, so this particular P we are going to use. So P containing right now 1, 2, 3 value. 1, 2, 3.63 we are having. So this is the first record we are going to load. Okay, this is the first record we are trying to load from this particular tree set here. So what is the method we are calling? TS dot first method. Now what do you understand? Whenever we are calling the first method, we are trying to load the left side records. Okay, for the last, for this particular last year, what we need to understand? We need to understand Here only I am going to call. So otherwise, I will copy this and I will comment out this particular first method, and I'm going to call the last method. Okay. So last method, by without checking this particular code, what we can understand here, we can easily understand this. Getting the point? We can easily understand this. It's trying to call the right side values. Okay. Now you can see, we'll debug this example one more time. Getting the point? This is important. We need to understand here. Whenever I'm trying to debug this, now observe carefully. So I'm moving inside this particular last here. We are calling m dot last key. Again, I'm trying to move inside this particular m dot last key. Now you can see get last entry. Here we called earlier get first entry. Now I'm calling get last entry. So this is the differences we need to identify for the first record as well as last record here. Okay. Now root here. What is the root we are going to get? Same thing, 89 here. So 89 is our root. But if you see here, we are trying to call right records here. We are trying to call all the right records here. So this is important here. Now we call the p dot right. So what is the p dot right here? 89 will contain 45. I'm expecting, yes. So 45 we are having the right record. Now after this p dot right we are setting one more time. It is trying to set, and here it will contain the 56. Oh, it is not, sorry. So it is containing 12. Most probably the 56 section is move on to the left side. Now if you see the expression, if I'm going to add here, we can easily understand here p dot left. Okay, p dot left. Whenever I'm trying to set this p dot left here, it is loading 56. And here whenever I'm trying to call this particular p dot right here, what is the value we are loading? 12. Okay, 12 value we are loading. After this particular 12, again this particular loop is going to repeat one more time. Now you can see this is the last iteration I'm expecting is now 10 value. So 10 value cannot have any right side value. This is the smallest value. Now if I'm going to run this p dot right, we don't have any values. Simply it is returning null. Now observe carefully how we are writing this particular while loop. Here we don't have the particular braces here. We are not using multiple lines, only single line. So that just we declare this particular while loop, and inside the while loop we define as a one statement like this. Okay, one statement like this. This is important information we need to understand whenever we are trying to write a single lines here. Any code, any condition, any switch case. Okay, we can write without the brackets here, because single line without the bracket it will work. So we discussed in the last session one more time, but finally p dot left is a null, so this while loop is not satisfying the condition. Directly it is returning this particular p. The p value right now it is containing the 10.41. okay, 10.41. so this is the last value only. Getting the point? So this is the way of loading the all the values here. Getting the point? This is very important internally how it is working this particular tree set. So any questions here? Anyone having any questions so far? Whatever the method we discuss here, the comparator, first method, last method, head set and tail set, subset. These are all the 5 or 6 method we discuss here. Anyone having any question?
Sir, everything is clear, but why is 89 the root always?
See, basically this 89, whenever we are trying to call this particular add all method, so at the time only the root is going to define here.
So is it
Okay.
like the middle value or something like that?
Basically, so yesterday we discussed how this particular root is constructing here. Now if you see, first record we will insert as a 45, and for this particular 45 we are comparing with this particular 89. Okay, so here we are getting the less value, because 45 is a less value compared to this particular 89. So in this case we are going to get as a -1, so that it is trying to set as a left value. And whenever we are trying to discuss about this particular 96, So we are comparing with the 89. First we'll compare with the 45. Later we'll compare with the 89. Okay, when we are trying to comparing with this, so we are getting greater value. So because of this particular greater value, we are trying to store as a right side section. So this is the way of internally it is trying to set the value. So here, now let me show you this value. First root, by default root will be null. By default root will be null. Whatever the record we are going to insert first record, this we are making as a root. So first record, this is we are calling the line number 16, 45.12. Now the root, what is the root record we are having? 45.12. Now after calling this, now again I'm going to call the second record. So 89 I'm calling. Whenever I'm calling this 89, internally we are calling compare method. We are calling compare method. So first key, here I am going to provide 89, and the second key here I am going to provide the 45. So which value is the bigger value? 89. So because of this, what happens internally? We'll get this particular -1. Whenever we are getting this particular -1, this 89 is moving into the root. Getting the point? 89 moving into this particular root, and this particular 45, whatever the 45 we are having, the 45 we are trying to set as a left to variable, and so still this 45 is a root. Whenever we are calling this particular third record, now it is replacing this particular root is replacing this. Now what happens internally? First 96 is going to compare with the 45, and later 96 is going to compare with 89. Because of this comparison, every time in the two cases 96 is a bigger value. So now it is pointing to right side value. After this, we are making this particular root of this 89 here. So this is the way of the code we implemented inside this particular tree set. So it is going to take care of anything. Now, if I'm going to store some other values, we'll understand this. Here I will modify something like 101.25, and I will remove this all the values so that we'll understand here. 49.87 and 63.12 and 74 dot something like 84 and 97.32, and here I'm going to provide 145 dot something like 64, and here now what I will do, here I'm going to change the last record. It is add only, right? 73.67. Okay, and first we'll identify the ascending order. To modify this ascending order, now what we can do, here we need to replace this value. First value, it should compare with this particular second value, not the second value with the first value. So this code is giving the comparison like ascending or descending order. Now I'm trying to converting into the ascending order. So if we observe carefully, we'll try to debug little bit faster here so that we can understand here now how these objects are going to inserted into this particular tree set here. First record we are inserting. Okay, again I'm calling this particular add method. So we are calling the put method root here. So root basically now it is null because we are inserting first record. We are calling the comparator. Sorry, we are calling this particular compare. Now we are creating the entry record. So what is the entry record we are creating here? Something like 101.25, because this is the first record we are trying to insert into this particular tree set. So this is clear. Now size we are increasing, returning null. After this, I am calling one more record. Okay, anyway, we will call one more record here. So this is the one more record I am calling here. Now after this, so what is the value we are passing here? 49. We are passing this particular 49 as a second record. Now you can see root just now we like initialize this particular root element something like 101. So this T, it is not null here. Now it will go to the comparator. We are having comparator. So we are having object here. the CPR is not equals to null. So now observe carefully. Here I'm going to call 546. So this is important here. And what is the T we are having right now? The T 101.25 we are having. And now I'm trying to set into the parent. We are calling the CPR dot compare here. Now what is the value we are going to get? What is the key right now? 49. And T dot key 101. So here, if you observe carefully, the CMP we are getting -1. Okay, CMP we are getting -1. So why we are getting the -1? This key is a less value compared to this particular T dot key. Getting the point? T dot key. T dot key is the 101 value. So I am going to write this. Where is this? Now if you see T dot key we are having 101 and this key we are having something like 49. So this 49 is a like a smallest value compared to this particular 101. Whenever we are doing this, so it is look like the operation like this, 49 less than 101. So this section will give you the -1. If you are trying to write this 200 less than or equal to 101, this section will give you the positive value because 200 is a bigger value compared to this particular 101. So this is we need to understand. This compare to only, sorry, this compare only, it is giving the this one is a like this value we need to set into the left side or we need to set into the right side here. Now if we observe carefully, we are getting -1. Whenever we are getting the -1, now we are trying to set as a left. So here we are loading, but in the below section we'll set this particular value. So left side value. Right now we don't have any left side value. So T is null. Once the T is null, what is the parent we are having? 101. Okay, the parent here 101 we are having, the key 49 record we are inserting with help of this particular relation here. Now parent dot left, getting the point? Parent we are having 101, the parent dot left we are trying to set as a E. The E is something like 49 records. After setting this, we are going back to the size increase, mod increase. Now we are going back to the null and we'll come back to this. So now 63 record I am inserting. So this is the third record. As of now, root element is a 101. Okay, root element is a 101. Now, whenever I'm trying to call one more time, now we are calling this particular comparator because right now you can see root still it is a 101. The first record only, now it is playing as a root node or root entry. Sorry, it is not a node, root entry. After this, it is a comparator it's calling. CPR is null, not equals to null because this comparator we implemented explicitly here. This is important here. If you are not writing this particular code, it will return as a null. So this particular code we are not going to check. We'll move on to this section here. This section, yesterday we discussed this particular section. Now we are discussing this particular section. Why we are discussing? Because comparator we provided explicitly. Okay, this is important. Now after this compare method, it is going to call this compare only. This is the compare method it is going to call from this the line number 550, whatever the compare we are trying to call. Now if you see, this is the comparator object here, tree set comparator. Okay, tree set comparator object is in itself is providing this. So now you can see tree set comparator. Where we created this particular tree set comparator? Here only we created here. Okay, here only we created this. So this is important, we need to understand here. Okay, back to here. Now what you need to understand is the parent we are loading. The parent now it is 101 and what is the key we provided? 63 something. Yeah, 63 and 101. This is also will get as a minus value. Now you can see minus value we are getting. 63 is a less value compared to this particular 101. Now again it is satisfying. So T dot left. So right now we are having one record. What is the T dot left you are having? Something 49 something. 49 we are having. Okay. Now you can see it is loading. Now 49 with 63. Now we'll get as a positive value. Now if you see this, we'll get to positive value. CMP will return as a 1. Earlier it is written -1, now it is returning 1. So if you see -1, 0, +1, based on this particular values, the order is changing here. The order is changing. This is important. Now whenever I'm trying to load, so this particular condition is not satisfying right now. Now the condition is satisfied by this, else if. Okay, right side, we don't have any records. So the T is null right now. The particular T is null. After this, the loop is stopping here. We are coming back to this. What is the parent here? Parent is now modified here. So 49 is our parent. Okay, after this, what we are doing here? Parent dot right side. Parent dot right side, we are trying to inserting 63 record. Okay, so after this, now again, I'm moving into the same, the tree set demo class here. So 63 is completed. Now I'm checking 74. So we'll run this particular 74. Now you can see what is the root we are having, 63. Why now it is modified this root here? Getting the point. So now why the root is modified here? Because if you observe carefully why it is modified here, we need to understand this first. So earlier root dot key, what we are having, 101. Whenever we are trying to inserting this particular 63 record, what happens internally? This is important here. So 101 and we are checking this 63. So it is a less value, so that we are getting the -1. Whenever we are getting the -1, we called the line number 552, we load the left side value. So whenever we are loading this particular left side value, something like a 49 record we are loading, 49 less than 63. Okay, 49, sorry, not this, wrong, 63 less than 49 here. 49, because the T is replaced with this particular 49. So currently the T is 101. Later it is replaced with this particular 49. Now we are checking this. So here we are going to get positive values here. When we are getting this particular positive values, at the time it is identifying here. At the time it is identifying. So this is the root node, because if you observe, left record is having and right side also we are having. This 63 we are going to make as a parent here. Now 63, it is contained in the right and left. Right we are having 101 and left we are having 49. Getting the point? This is important here. One left should be available and one right should be available. Then only we are going to make this is as a root element. Okay, this is the particular record we are making as a root. Now observe carefully, 63 is our root element. Now is it clear? Any questions here? Okay, I'm expecting I did not receive anything, so I hope you
It's
don't have
clear,
any.
sir. Thank you.
Okay, now we'll go back to the another method what we are having. Now you can see this is the last element we are trying to load, something like 145.64 here, and this is the first record 10.41. Okay, this is the way of loading the ascending or descending order. By default it will load ascending order by default. So which comparator it's going to work internally? This comparable. Okay, this line number is going to execute line number 563. But whenever we are making explicitly, this section will call 546. So this is the differences we need to understand regarding this particular tree set here. Now, what are the method we are pending? So I hope the sorted set also it's completed. Now we'll move on to the navigable set. The navigable set basically what we can understand here, this is lower method, floor method, and ceiling method, and higher method. Now you can see, so here we are having conditions here, less than condition, less than or equals to, or we can check with the less than. Up to the less than, whatever the value I'm providing here, so it will try to load the all the values. So we'll see how this particular lower it is implemented inside this particular tree set. So this is important. TS dot lower method I'm calling, and I'm trying to give 75. 75.23. Getting the point? This is important. We need to understand here how this particular 75 it is going to work internally. So this is the lower record. So what is the condition we are going to use? Here we are going to use less than. So less than to 75.23. Okay, less than to 75.23. Whatever the elements we are having, all the elements are it's going to load, only one element it's going to load. Because if you see the lower method, it's returning only one element. Not it's not a type of collection. It is having only single element type. Like it's like a single object type here. Getting the point. Now if you observe carefully, here we need to understand how this particular lower method is going to call. Now I'm enabling this particular breakpoints here. So we need to debug this particular lower method, how it is working internally. Let me remove the breakpoint here. Now we are at lower method. Now I'm trying to move inside this particular lower method. So if I want to move inside this particular method, what is the shortcut keyword we need to use? Getting the point. These are all the shortcut keyword I'm trying to explain one more time. F5, okay, F6, and F7, and finally F8 here. These are all the four the shortcut keyword we need to use whenever we are trying to debug the application. So F6 will give you the line by line. Okay, line by line. What about this particular F5 method? Inside the method or inside the block I can write. Okay, inside the block. If I want to move inside this particular block, you can click on this. So this 7 come out of the block. Okay, come out from this particular block here. And this is basically breakpoint to breakpoint. Getting the point? So breakpoint to and breakpoint here. This is important. Breakpoint to breakpoint here. These are the four shortcut keywords we need to use whenever we are trying to implementing application with the help of this particular Eclipse. Okay, STS and Eclipse will have same shortcuts here, but when you are trying to use a other ID, you need to check what are all the shortcuts for the debugging the application. Okay, so this is for the STS as well as our Eclipse, whatever the Eclipse IDs we are going to use. Okay, now back to here. I'm clicking on this particular F5 because we need to move inside this particular method. Now I'm calling this double here. Again, I'm going to check on this particular value. Now you can see m dot lower key. Okay, m dot lower key, we are having this particular method here. This is important here. Whenever we are calling this particular lower key, now what I'm doing here, again I'm trying to call lower key method I'm calling and key are null. So this is basically, it will return internally key or null here. So finally what I'm doing here, get to lower entry method. Getting the point? So we identified get first entry, last entry, and the same way we are having lower entry method we are having here. Now we'll identify how it is implemented here. Now we need to identify how it is implemented internally. Let's observe here, I'm trying to move inside this particular get lower entry. Okay, root here. So what is the root we are having? 74. Now if we observe carefully what happening internally, it is trying to check this particular value, and again we are trying to comparing this value. When in this particular value it is satisfied, now you can see, so inside this particular tree set or tree map, we use multiple times this particular loop here. Okay, we use it this particular loop multiple times here. Okay, so compare we are calling. Now you can see what is the value I'm getting, positive value I'm getting, because the key, whatever the key I provided, 75.23, and p dot key, the p dot key what we are having, 74.84, and it is 75. Okay, so it is 75 because this particular 74 and 75, 75 is a bigger value. Because of that, now it is written as a positive value. Now after this, we are checking this. Now you can see CMP it is not like greater than 0. P dot right. What is the P dot right? We are going to get basically 97. Okay, 97 we are loading. So again this particular loop is repeating. Yeah, this particular loop will repeat here. Now you can see right now the parent record is 97. Okay, and again we are checking here. Now this time we are going to get minus value. This time we are getting minus value. Okay, here we are having only greater than 0, and here we are checking the left side here. So P dot left. What is the P right now? 97.32. So if I'm going to check this P dot left 75. Okay, 75.23. Now what you are understanding is, now we are trying to load this particular P dot left here. And what is the P? Now it is replaced with 75.23. And what is the key we are providing? Same thing, 75.23. Getting the point? This is important here. Both keys are it's going to match here. Because with help of this particular P dot left, we load 75, 75.23. And the key also we provided 75.23. Okay, after this, now what happens internally? This particular loop will repeat here. Okay, this particular loop will repeat here. Now again, the compare. Now what is the value we are going to get? 0. So why will get 0? Both the values are same. Now you can see 0 we are getting. So whenever we are getting this particular 0, this condition will not satisfy. This condition will not satisfy. Okay, it will move on to this else section. There is no else if section. So that it will move on to the else section. Now you can see else section is satisfied here. Once if it is fail, directly it will go to the else section. But P dot left. So P dot left, what are the values we are having? Something like null we are having. Something like null we are having. Whenever we are having null, now what happens internally? So inside this particular else, again we are having the nested else. Getting the point? Inside this particular else, again we are having nested else statements here. Now you can see P dot parent. Okay, P dot parent we are having. So whenever I'm trying to load this particular P dot parent, again we are loading the 97 here. So 97. So we are loading parent and child record. We are matching here. So parent and child is matching. So once it is matching here, parent dot parent. Okay, parent dot parent. So what is the parent right now? 74. Now you can see 74 is not matching. And what is the child record we are having? Something like 97. And here we need to identify what is the value we are going to get. 63. This is not matching the condition. So we are returning parent. So what is the parent record we are returning? What is the parent record we are trying to return here? Now if I'm going to show you, it is not returning. We'll go to the key method. What is the record we are loading finally? Here if I'm trying to see 74. Okay, 74 record we are trying to return. So this is the less than record here. What is the value we provided? Now if we observe carefully, we given 75 value. Okay, we given 75. So this is the original value we given, but we are checking the nearest less than value. The nearest less than value what we are having? 74.84. The 74.84 it is returning here. Okay, this is important. We need to understand. This is the nearest less than record here. Because if we observe, we'll have 10 also less than only, something 49 also less than, and 56 or 59 something we are having. This is also less than here. But why these records are not returning here? Because for this particular 75, this is the nearest one. It is having less than record here. So this is the method is going to loaded by the, what is the method we are calling? Lower method. Okay, what is the method we are calling? Lower method. This is important here. We are trying to returning something like the value. I will print this. Here I'm going to print this particular value so that we'll understand here. Here we can easily understand the what is the value we are getting. The value we are getting 74.84. So what is the value I given? 75.23 I given, and I'm loading this. So because this is the nearest to less than value, less value. Okay, or we can call it as a small value. Getting the point? This is the small value we are having here. Any questions so regarding this particular lower? Anyone having any questions? Basically, it is a simple one. Whatever the input we are going to provide, or we can call it as a whatever the parameter we are providing. So it will try to identify the, based on this particular parameter, what is the nearest less than value we are going to have inside this particular tree set. It will try to return the nearest less than values here. Okay, so that we are discussing inside this particular lower method. Now, what are the other method we are having here? The another method we can see floor method. The floor method, if you see here, here only it is showing the information less than or equals to or less than. Okay, now if I'm going to run this instead of this particular lower, if I'm going to run this particular floor method, now we'll see what is the value I'm getting. The value I'm getting here 75. 75 I'm getting. If the 75 is not available, it will return the less than value. Okay, 75 if it is not available, it will return the less than value, because 75 it is available. So this is the value it is returning. Okay, less than or equals or less than value. So it will do the two steps of operation compared to this particular lower method. Floor is doing the two steps of operation. Now we'll see. Sorry, we need to go to the implementation, and the implementation we need to see inside the tree map. Okay, we'll see here lower entry. Okay, so it is calling lower entry, and it is trying to identify this particular code, because while seeing this particular code we can easily understand what happening internally. Based on this, we can easily understand the which value it is trying to return. Getting the point? This is important here. The floor and the lower method both are same, but only the one condition. Lower will check on the left side value like less than value, and floor less than or equals to both values it's going to check. So this is the differences. Now you can see ceiling we are having. This method is trying to check on these two operations, greater than or equals to or greater than. Now first we'll discuss about the higher. So whenever I'm trying to give the same, here only I'm going to give the same higher here in place of this floor. What is the higher value we should get? Something like 96.52. Okay, now we'll see what is the value we are going to get here. So 96.52 we are getting, because we given this, and this is the nearest to greater value. Getting the point? This is nearest to greater value we are having. This is important, we need to understand. Okay, so this is a way we can identify this particular higher method. Now finally, the what is the method we are having? So this is the ceiling method we are trying to call here, and now it will give you the same value. It will give you the same value, because here we are using equal condition. Whenever you are using this particular equal condition, so first it will give you the highest priority to the current value. So the current value is satisfying the condition. Okay, current value, now it is satisfy the condition. This is important, we need to understand how this particular, these four methods are working internally. So we discussed these are all the four methods, how it is going to work. And finally, the pool first and pool last, same thing. Whatever we discussed here, first and last here, the pool first and pool last will do the same operation. But what we need to check internally, so this is the information we need to identify how it is going to work internally. TS dot the pool first method. Getting the point? Pool first method, how it is work internally. Now if I'm going to call map dot pool first entry. Okay, here now you can see only one difference is we need to understand. Here, null. If it is this particular E is null, we are going to return as a null. Only this is the changes we are going to have. If I'm going to show you the example on this first method as well as this particular full first. Now we'll call this particular same one more method, ts dot first method. Okay. Now I am calling this method also. So we are calling m dot first key, we are calling it. Now you can see. So get first entry. Now what happens internally? This is returning the first entry record. Whenever it is returning this particular first entry internally, we are calling this particular key. Now if this particular E is null, we are throwing an exception. Okay, first and last will throw an exception. For this particular full first and full last, we are not going to throw any exception. Even the specified record is not available, simply we'll return as a null here. Getting the point? This is only the differences we are having here. Now you can see carefully. Here we only it's showing the information how this particular exception is trying to throw. Okay, how it is trying to throw this particular exception here. So finally, we need to discuss about the differences we identified, full first and full last year. Okay, so we discuss about the headsets, tail set and subset. These are all the same here, but only the differences we are having inclusive parameter. This method, the headset and tail set method internally, it is calling on this particular same information here. Okay, this is all about the one of the important information we are understanding from this particular tree set here. So, tree set is a very important example we discuss here. So compared to this particular hash set, linked hash set. Okay, hash set and linked hash set it will use a hash map, and linked hash set internally it will go for the linked hash map because okay, and another one tree set. Tree set internally it is using the tree map, but tree map it is giving the lot of information to provide the ascending or descending order. Okay, so these are all about the implementation about the set interface. So we'll tomorrow or we can discuss in the today evening class the queue related section. So queue interface, how it is going to work here, and what all the queue related method we are having, and how this particular DQ is implemented here. Okay, how this particular DQ is implemented internally, we are going to discuss. These are all the sections are pending. We'll continue the same session evening. Okay, so any questions regarding our today's session? Anyone having any questions?
No, sir. Thank you.
Okay. Uh, Someone is asking the question. See, floor method basically you can see here. Where is this floor method? If this particular less than or equals not satisfied here, it will check on the less than operator. Okay, so this is the two way of performing the operation here. First, it will give you the highest priority comparing the current value. If you are not finding any record with the current value, it will try to check about the left side value. What about this particular the values we are having? Okay, maybe we need to see whether this particular method is implemented any exceptions or not. So let me see. And key or null. So simply it is returning null only. This method is not going to throw any exception. Now here you can see if this particular E is null, it will return null. Otherwise, the E dot key, whatever the value we are going to have, the particular value, it is going to return. Okay, I hope it is clear. So any other questions? Okay. So if we don't have anything, so we'll continue evening.
Thank you, sir.
Thank you.